Assalamu alaikum. Today I am going to explain you how we can find the mass of Earth using the Newton's law of gravitation. We know that according to Newton's law of gravitation, the force of attraction between two objects is equals to F is equals to F, and its value is G into m1 m2 upon r square. Suppose that circle is representing Earth, and this circle is representing a ball lying on its surface. This distance from center of the earth to the surface of the earth is radius of the earth, and this is the radius of the ball. In comparison, the radius of the ball is so small that it is almost negligible. When we are calculating the radius of earth, the radius of the ball will be a few centimeters, which will be negligible when we are expressing both the two together. The mass of the earth, I will take it as me, and mass of the ball will be taken as m. Now, if we replace these values which we discussed in this diagram in the given relation, which is F is equals to G m1 m2 upon r square, we will get F is equals to G m1 will be the mass of the earth. I can represent mass of the earth by me, and m2 will be replaced by mass of the ball, which is taken as m, and the distance between the two will be only r. We are neglecting the radius of this ball because it is negligible, as we discussed earlier. So the radius of the earth will be the distance between their centers, and we know that it must be squared, so we will square it. Now we know that the force of attraction between the two objects, that is earth and the ball, will be the weight of the ball. The weight of the ball can be taken as mg, so the force can be replaced by mg, which is representing the weight of the ball. We know that w is equals to mg, weight is equals to mg, which is the force that is being applied over here by the earth on the ball. Now I have replaced force by mg, so we can say that force or weight mg is equals to g me m upon r square. Now we are noting that m is present on both sides of the equation, so it can be cancelled out. Then more simplified equation will be G is equals to capital G mass of the earth divided by r square. Since we are interested in calculating mass of the earth, so we can shift radius of the earth on the other side, and this G will be divided over there on the other side of the equation. So our equation will become G is equals to G into re square upon G is equals to mass of the earth. So this relation, which I have noted right now, is representing that the mass of the earth, if you want to calculate, will be G multiplied by radius of the earth squared divided by gravitational constant G. Now we just have to simply insert the value of acceleration due to gravity, that is G, radius of the earth and its square, and gravitational constant to find the mass of the earth. Now we just have to insert the value of G, re square and gravitational constant in this equation to find the mass of the earth. The value of acceleration due to gravity is 9.8. I'm not writing the units, I'm just noting down the numbers for more easy calculation to avoid confusion. The radius of the earth is 6.37 into 10 to the power 6 meters, and we have to square it. and the value of gravitational constant is 6.67 into 10 to the power minus 11. Now mass of the earth will be 9.8 multiplied by the square of 6.37 is 40.57. So 40.57 will be noted for this value, and 10 to the power 12 will be the square of this, and 6.67 will be the denominator with 10 to the power minus 11. Now when we divide 40.57 by 6.67, the result will be 6.08. So we can write mass of the earth as 9.8 multiplied by 6.08 into 10 to the power 6 divided by 10 to the power minus 11. On shifting 10 to the power minus 11 above it, this will be 12, sorry, this will be 12, this will be 12. Now when we shift this minus 11 above, then mass of the earth will be 9.8 into 6.08 into 10 to the power 12 plus 11. So mass of the earth will be 9.8 into 6.08 into 10 to the power 23. Multiplying 9.8 by 6.08 will give us 59.61 into 10 to the power 23. Then shifting decimal towards left will make it 24. So mass of the earth will be 5.96 into 10 to the power 24. So we can say that mass of the earth is approximately 6 into 10 to the power 24 kilograms. Hope this will help you in us understanding that how we can calculate mass of the earth. Thank you.